Over the next 2 days, we're going to be talking about multiplying and dividing rational expressions. Today, we're just going to talk about the multiplying part. So here's the good news. Well, actually, I'll give you the bad news first. Bad news is it's like what we did yesterday. The good news is it's like what we did yesterday. So here, let me explain why it's good news. It's bad news because, well, factoring's a pain in the butt, right? So we're going to keep doing that today. But well, I hope you guys do find it to be that easy. But the good news is that what we're learning today, you don't have to learn anything new, really. It's just that when you're multiplying, you're doing two of them at the same time. But it's the same process exactly. So let's go ahead and go through and see how these things pan out. I want to start this slide back over. Sorry. All right. So you don't need to write this, but I just thought maybe I would show you a familiar example. Now, you guys probably know how to multiply, right? Fractions. You just multiply the tops, right? And you get 30 over 40, and then you can reduce it to 3/4. Now, there's another way you can do it, and I'm about ready to show it to you, and you're going to think, well, that was ridiculous. That's like a whole bunch of extra work that I don't want to do. But the reason why I'm going to show you it in that way is because that's how you do it with what we're doing today. So let me show you guys how it works here. Notice that I multiplied first and then I reduced. The way I'm going to show you do it today is to reduce, then multiply. And the purpose in doing that is it keeps the numbers smaller so you don't have to wonder about how to reduce them at the end. But let me go ahead and show you this example, the way we're going to hit rational expressions up today. So before you multiply, the first thing I'm going to do is break them apart so I can see all the factors. So notice that the 6 becomes 2 times 3, the 10 becomes 2 times 5, etc., etc. Okay, any questions? Now here's the neat thing. When you're multiplying, notice that when I did that example for you, you basically just multiply the tops together and the bottoms. In other words, it can become just one big fraction. Okay? Which means that if it's just one big fraction, then factors that are in the fraction on the left can reduce with factors that are fractions on the right. So what factors now match on the top and bottom? You could take a 2 and a 5 out, right? Which leaves us with 3 over 2 times 2, which is 3/4. The same answer I got doing it the other way. And you might think, well, that's ridiculous, a lot of extra work. But that's, unfortunately, the only method that we have at our disposal when we're working with rational expressions, not just number fractions. So, moving along. Okay, so let's go ahead and try some problems here. Go ahead and write down number 1. Do that. So, if we factor these, 4x to the third over 3x times 14 over x. Here we go. Now, 4x to the third. 4 is what? 2 times 2. And x to the third is 3x's, right? All right, and the bottom is just 3 and x. You really don't need to rewrite that. 14 is 2 times 7, right? And x doesn't factor at all. It's just x. So now we're ready to start crossing stuff off. Now, I guess I'm not being a good example here. My handwriting's not very clean. But the neater you are with this stuff, the better off you are because you're less likely to miss things. So here we go. Let's just start on the bottom left here with the 3. Is there a 3 on the top I can take out? No. And now notice you can look at any fraction. I can look at the fraction on the left or the right. There's not a 3 in either place? Okay, moving along. So x, is there a x on the top? Yeah. So we can cross off an x. One x off of the top and off of the bottom. Moving along, the next one is x. Is there another x on the top? There is. It's in the other fraction, but that's okay. That's the beauty of multiplication. It doesn't matter what fraction they're in. All right, so we got everything crossed off that we possibly can. So let's go ahead and see what's left then. On the top, I've got 2 times 2, which is 4, times another 2, which is 8, times 7, which is 56. So I've got 56 on the top. And there's also what else on the top that I kind of skipped over? An x. So it's 56x over 3. All right, so as you guys can see, the top one cannot be factored on the top left, but the 8, if we did a factor tree, it would become 2, 2, 2. The top right is a monomial, so we would just do a factor tree and we get 2 and 3. And the bottom right is a difference of squares. And what would it be if I did the difference of squares? T plus 3 and t minus 3. Now we're ready to start crossing stuff off. So it doesn't matter whether you want to do the top or the bottom. I'll do the top this time. Let's start with the t plus 3. I've got a t plus 3 on the top right here. Is there a t plus 3 on the bottom right or anywhere? Yeah, right? So I can take this t plus 3 away and this t plus 3 away. Now moving along, I've got a 2 on the top. Is there a 2 on the bottom anywhere? There is. So I can take this 2 away and this 2 away. And the last one, there's a 3 on the top. There's no 3 on the bottom. Some people might think, well, there's a minus 3 right here. But remember, that's grouped with the t minus 3, right? So that's, you can't take that 3 out. So basically, here's our final answer. On the top, I'm left with only a 3. And on the bottom, I've got 2 times 2, which is 4. And then I've also got the t minus 3. So there's your final answer. So here's some for you guys. Okay, guys, so I'm going to put the answers up here so you can check your work. For the top one here, we should have 2 over dc squared.
Does this matter if I put c squared d?
For 2 should be 1 over m minus 1.